Just Stoich problem. These are the most common that you're going to do, and these are called gram to gram problems. So we started off when we did mole to mole. When we did the mole to mole, we were kind of learning the heart of any Stoich problem. When we learn this heart of any Stoich problem, you were given moles of one component, something like lead 2 sulfate or something, or lead 4 sulfate in this case. And we wanted to know, I don't know, how many moles of lithium nitrate we needed to react with it. In order to do that, we needed the mole ratio. The mole ratio comes from the balanced reaction. So these were just a one-step problem. And then we, in the last video, maybe went from grams, and we needed our answer in moles of our unknown. And we learned that in order to get rid of grams and go to moles, just like in the last unit, we used the molar mass conversion factor. Or maybe they gave us moles, but they wanted your answer in grams. So again, because we have moles straight off the bat, we don't need to use the molar mass of your given components. You just go from moles to moles by using your mole ratio. And then we went from moles to grams by using your molar mass. So on these problems, you're going to do the same process over and over and over. You're going to take your molar mass of your given component. You're going to use that to go to moles, mole to mole ratio. And then you're going to take those new moles and turn it into grams by finding the molar mass of your second component. So what I mean by that is, it says how many grams of lithium nitrate. So with my lithium nitrate, I want grams of that guy right there. Will be needed to make 5.2 grams of lithium sulfate. So I have 5.2 grams of this one that is necessary for whatever component there is. And this happens a lot of times in like industry. The company says, well, we need 1,000 grams of this. And if you need that many grams of it, they're going to need to figure out how many grams you need to start with to react in order to produce that amount, because they don't want to be wasteful. They don't want to over or under whatever it is. So you don't always have your grams with your reactants. Sometimes your grams are with your product. I just kind of wanted to point that out, that is something that happens quite a bit. So you always start with the number that's given in your question, where you have 5.2 grams of lithium sulfate. And if we're starting with grams of lithium sulfate, we know that we're going to have to get rid of grams and go to moles. To get rid of grams and go to moles, I'm going to have to find the molar mass of lithium sulfate. The next step, once I have moles, I'm going to use my mole-to-mole ratio. The mole-to-mole ratio comes from the balanced reaction, so I'm going to have to balance this out. And then once I have moles of my lithium nitrate from my mole ratio, then I have to take my moles and go to grams by finding the molar mass. So there's some legwork that I need to do before I actually do this problem. First step is I need to balance my reaction. Then I have 2 molar masses that I'll have to find, and then I can actually do the Stoich problem down here. So when I go to do this problem, this has 2 lithium. There's 2 lithium. That gives me 2 nitrate. Here I have 4 nitrate. So I'm going to change this to a 4. So now I have 4 nitrate. Now I have 4 lithium. I'm going to put a 2 right there. That changes my lithiums to 4. That gives me 2 sulfate. There's 2 sulfate. 1 lead, 1 lead. That's a balanced reaction. Now remember in the blanks there are 1s. They're ghosts, but I'm going to write them because I might need them for my mole ratio. Now the 2 molar masses that I need, I'm going to have to find the molar mass of lithium nitrate, and I need to find the molar mass of lithium sulfate, because those are the 2 components that I'm looking for in my reaction. So I'm going to do lithium nitrate first. So I'm going to find the mass of lithium on the periodic table. When you locate lithium on the periodic table, it has a mass of 6.94. There's 1 of them. Plus the mass of nitrogen, which is 14.01. Plus the mass of my 3 oxygen, which is 16. So my molar mass of lithium nitrate is 68.95 grams for the mass of 1 mole. So that is that molar mass right there. Now I'm also going to find the molar mass of lithium sulfate. So again, lithium, when you find it on the periodic table, has a molar mass of 6.94 times 2. Oh, I meant to keep going on that one, sorry. So I have my 2 lithium plus the mass of sulfur, 32.07, plus the mass of my 4 oxygen, so 4 times 16. So the molar mass of this one, for the mass of 1 mole, is 109.95 grams. So that's my second conversion factor that I'm going to need for this problem. So now that I have a balanced reaction, I have both of my molar mass conversions, I can do the problem. So first step, I have to get rid of grams and turn it into moles. So I'm going to use my molar mass, 109.95 grams of lithium sulfate is the mass of 1 mole of lithium sulfate. Now notice I am marking down which component I'm using. In this case it's lithium sulfate, just so I don't get lost later on. So that cancels, that leaves me with moles. Once I have moles of lithium sulfate, moles of lithium sulfate goes in the bottom. Moles of what I'm looking for in the question, the unknown, goes on top. So in this case, it is lithium nitrate. So my moles of lithium sulfate is 2, because there's a 2 right here. Let me drop that right there. My moles of lithium nitrate is 4. So it's a 4-to-2 ratio. For every 4 moles of lithium nitrate that you start with, you're going to end with 2 moles of lithium sulfate. Now in the next step, I need to get rid of moles of lithium nitrate and turn it into grams. So 1 mole of lithium nitrate, molar mass is always 1 mole. That's why I drove it in. You have to write it with 1 mole last unit. That is just to be helpful for you. 1 mole of lithium nitrate has a molar mass of 68.95 grams. That's what we found right here. So we found that molar mass, we dropped it in here. The only time you don't have the number 1 with mole is with a mole ratio. So this is always equal to 1 mole. This is always equal to 1 mole. So now, when I go to do my problem, I'm going to get my calculator again, and you have to multiply all the way across the top first. So in my calculator, I'm going to take 5.2 times 1 times 4 times 68.95. Multiply all the way across the top first. So 5.2 times 1 times 4 times 68.95. And I'm going to hit equals at the end down here. Then I'm going to hit divided by. Then I open parentheses. And again, I'm going to multiply all the way across the bottom. So 109.95. Again, I have to open parentheses here, otherwise my calculator is going to order of operations weird, and it's not going to give me the right answer. So 109.95 times 2 times 1, which you can skip. And my answer ends up 6.52187, blah, 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 blah. My first number here has 2 sig figs, which means that I can only have 2 significant figures in my answer. So that's going to round to 6.5, and that's grams of lithium nitrate. I do have another one that we're going to do. This problem, it is a combustion reaction. If I do this reaction, so this one right here, with 45 grams of oxygen, so I have 45 grams of that guy right there, how many grams of carbon dioxide will be formed? So I know that I have grams, and I want grams in my answer. So if I have grams, I have to get rid of grams and turn it into moles so I can do my mole-to-mole ratio to switch it from oxygen to carbon dioxide. It's the magic switcher button. So we're going to start with my 45 grams of oxygen. I need to get rid of grams and go to moles by finding the molar mass of oxygen. I'm going to use my mole ratio, so I have to balance this reaction. And then I'm going to take my moles of oxygen and turn it into moles of carbon dioxide by using my mole-to-mole ratio. Then I'm going to take my moles of carbon dioxide and turn it back into grams by finding the molar mass of this. So the molar mass is the easier part. 1 mole of oxygen, each one has a mass of 16, so that's 32 grams. For my carbon dioxide here, 1 mole, has a mass in grams of 44.01 grams. So I was doing some math in my head. So it's 32 for my 2 oxygen plus 12.01 for my carbon. So I just added those together in my head, and that's my molar mass. Now my mole ratio, I have to use my balanced reaction. Remember, combustion reactions, you're going to balance your carbon first, and then your hydrogen, save your oxygen for last. CHO, C-H-O. So here's 6 carbon. I need 6 carbon. So now I have 6 and 6. My hydrogen, I have 10. 5 times 2 gives me 10. Now my oxygen, I have 2 here. On this side, I have 12 plus 5. 12 plus 5 is 17. I need 17 over here, but that's not possible without doing an 8.5, but that's not a legal move. You have to either have a whole molecule or you don't have a molecule at all. You can't have a half of a molecule. So that was where I said that you want to double your coefficients. So if we double our coefficients, right now there's a ghost 1 in this first spot. So I'm going to double that and make it a 2. I'm going to double 8.5. I'm going to make that a 17. I'm going to double the 6 and make it a 12. I'm going to double the 5 and make it a 10. So now if we recheck our work, we have 12 carbon and 12 carbon, 20 hydrogen and 20 hydrogen. And then for my oxygen, I have 17 times 2, that's 34. So then I have 12 times 2 is 24, plus 10 is 34. So that's a balanced reaction. So that's just a little trick to get around with your combustion. So now back to my problem. Since I have my conversion factors, I have my balanced reaction, I can actually do the math now. So I have 45 grams of oxygen. To get rid of grams of oxygen has to go in the bottom. We said our molar mass is 32 grams for the mass of 1 mole. So what that did for me is it turned grams, got rid of that, and turned it into moles. Now I can go from moles of oxygen, which in this case from my balanced reaction is 17 moles. Oxygen will produce 12 moles of carbon dioxide. So I used my mole ratio to switch it from moles of oxygen to moles of carbon dioxide. Now in the last step, I'm going to take my moles and turn it into grams. So 1 mole of CO2 has a mass of 44.01 grams of CO2. So that's the mass of 1 mole. That got rid of moles, it turned it into grams, which is what the question asks for. So now in my calculator, I'm going to multiply all the way across the top first. So when I multiply all the way across the top first, I'm going to take 45 times 12 times 44.01. I'm going to hit equals. So that's the answer across the top. Divided by, open parentheses, 32 times 17 times 1, which you can skip. Skip over the 1s because they don't mathematically do anything for your problems. And when we get our answer here, this number has 2 sig figs. So I have to run my calculator to have 2 sig figs, which is 44 grams of CO2. So if I start with 45 grams of oxygen, I'm going to produce 44 grams of carbon dioxide. I have one more that I'm going to do. For this last one, I don't have a balanced reaction, or I don't have a reaction given at all. So I'm going to have to predict my products, because it only gives me one product. After I predict my products, then I'm going to balance my reaction. After that, then I have to find my molar masses. This is why we need to know nomenclature. This is why we need to know sig figs. This is why we need to know dimensional analysis. Everything comes together starting with this unit. So it says that we are starting with 4.125 grams of iron 3 nitrate. So iron 3 nitrate is going to be FeNO3 3. This has a -1 charge. This has a +3. I swapped it up. I'm reacting it with sodium hydroxide. Sodium is Na+1. Hydroxide is OH-1. So you have NaOH. It says that I'm making iron 3 hydroxide for one of my products. I don't know my other product, so I'm going to have to predict it out. So when we predict our products, just kind of use a little bit of space over here. I have iron with a +3, I have nitrate NO3 -1, I have sodium, and I have hydroxide. So right now, I already know that these two crossing together are iron with my hydroxide. My other product is NaNO3. I have to know that because I'm going to have to balance this reaction out, and so I need to know how many sodiums and how many nitrates are there in order to balance it. So then, to balance everything out, I can only put coefficients in the blanks. That's 3 nitrate. I need 3 nitrate over here. That gives me 3 sodium, 3 sodium, 3 hydroxide, 3 hydroxide. That's a balanced reaction. Once you have a balanced reaction, you can fill in ones for the little ghost places. This one says that I'm starting with 4.125 grams of this. I want to know how many grams of sodium hydroxide I'm going to make in the end. So this is a gram-to-gram problem. If you have grams, you have to get rid of grams to go to moles because we have to do the mole-to-mole ratio. So start with the number that's given in the question. To get rid of grams, I have to know the molar mass of my iron 3 nitrate. I'm also going to need the molar mass of this guy down here, so I'm just going to calculate both molar masses just so I have them handy when I'm doing the math problems. So in this one, I have 1 iron. Iron has a mass on the periodic table of 55.85. Plus my 3 nitrogen, so 3 times 14.01. Plus my 9 oxygen. Oxygen has a mass of 16. So this molar mass, with a mass of 1 mole, is 241.88 grams. So that's that one. Iron 3 hydroxide. Again, iron has a mass on the periodic table of 55.85. There's only one of them. Plus my 3 oxygen, so 3 times 16. Plus my 3 hydrogen, so 3 times 1.01 is the mass on the periodic table of hydrogen. So when you add all of that together, this molar mass is 106.88 grams for the mass of 1 mole. So now I have my balanced reaction. I have both of the molar mass conversion factors, which means that I can get all this plugged in. So I have 4.125 grams of iron 3 nitrate. To get rid of grams, grams has to go in the bottom to cancel. So 241.88 grams was the mass of 1 mole. Once I get rid of grams and turn it into moles, that's when I can use my mole-to-mole ratio. My mole-to-mole ratio says for every 1 mole of the FeNO3, I have 1 mole of the FeOH3. So it's a 1-to-1 ratio. In my last step, I'm going to take my moles of FeOH and turn it into grams by using my molar mass conversion factor. And that says 1 mole of my iron 3 hydroxide has a mass of 106.88 grams. So moles cancels, moles of iron 3 nitrate cancels, that leaves me with grams, so now I can do the math. So to do the math here, again, I'm going to get out my calculator, and again, you have to multiply all the way across the top first. So 4.125 times 1 times 1 times 106.88. At the end of that, you're going to hit equals. So 4.125, times 1 times 1 times 106.88. Hit equals. Then I'm going to do divided by. This is times 1 and times 1. Normally we would open up parentheses here, but there's only one number that's going to go in the bottom. So 241.88. This number right here is 4 sig figs. So that means that I'm going to take my calculator number and I'm going to write it with 4 sig figs. So I have 1.82. The 7 makes the 2 go up to a 3. And that is grams of FeOH. So I hope that helps. Just remember that you always, if you're given grams, you have to get rid of grams by finding the molar mass of whatever is given, that compound. To go from moles to moles, so moles of your given to moles of your unknown, you have to use your mole ratio. Mole ratios come from the balanced reaction. Then you have your grams of your unknown down here. So to go from moles to grams, again, you're going to have to find the molar mass of whatever component it's looking for. The molar mass is always 1 mole is equal to whatever mass in grams from the periodic table. This mole ratio, you could have different numbers. It might be a 1, it might not be. We had a 17 in this problem, or in the last one, I guess. So it could be any number as long as it's from the balanced reaction. But this is always 1 mole is equal to whatever grams. This one down here is always 1 mole is equal to whatever grams. I hope that helps. If you guys have any questions, be sure that you ask.